Okay, welcome back. So I forgot. Hold on, let me transition over here. Okay, so um, I forgot that uh, my sister was not going to be able to do gym today. So we're back. um, but that's good. That's good. That means more study time for me, which is helpful. So we're going to do another block of studying. Um, Maybe more because I do. Well, it depends on how fast I can get through this module. Um, but I do want to try and finish up the uh, Calc 1.3 that I've been working on, or the homework, and then do some of the test review questions. Try and see if I can do those. And then after the lecture tomorrow, I'll do that again. I'm gonna try and stream tomorrow, but my class schedule's a little weird. So my first class is my calc class, and that ends at 10:45. So after that, my next class is at 2. So it's kind of a weird, what you call it? Kind of a weird schedule, but um, that class lasts until 3:15. So I guess I could try, let's see. Realistically speaking, I probably won't be ready to stream until like 12 after my first class. But I would probably be ready around 4:30 to stream after my second class. So I could do that. And then Wednesdays I don't have. Oh, I forgot. I was supposed to go to the Wednesday. I'm not going to be able to stream because I just remembered I was supposed to go to the seamstress today. Drop off some stuff. So, yeah. Well, I guess no. I'll still be able to stream Wednesday. Um, it just won't be as early as I'd like. Probably late afternoon. Uh, kind of like. Oh well, no, I started at 12, right? I don't know. Probably sometime around this time or 3 o'clock. Either way, all right. I will be streaming. I'm gonna try to stream every day, um, except for Sundays and some Saturdays, because of work. So Sundays are just days I don't like to stream anyway, because I go to church that day and I just want to take the day to relax and rest and all that stuff. So I will try to stream all the rest of the days. Um, Tuesdays and Thursdays definitely going to be shorter streams, more difficult for me to stream because of my schedule. And then Fridays, I have lab 12 to 2:40. So those are going to be shorter streams as well. So I think Mondays are going to be the long stream or like the two-part stream like now, depending on gym. And then Tuesdays and Thursdays short streams. Wednesday longer, but not as long. Well, maybe about as long as Tuesdays, unless we're doing gym on Wednesdays, all depending. And Fridays definitely shorter stream. You know, I'm starting to think I should probably go to the gym in the morning. Maybe I should get my own gym membership, but it's fine. Um, can we get rid of. Oh my goodness, we've got spam in the chat. Block that. Block that. Oh, I'm gonna have to open, aren't I? Okay. I'm gonna have to open that up in Kick. Creator dashboard. I need to update my little thing as well. Let's delete. Thank you. Delete. Thank you. Ban. And ban. I'll have to do a split screen for this while I'm reading the thing. Okay, so let me get the module 2 up though. Module 2 notes. Oh, that's full screen? No, I don't want full screen. Am I gonna have to download it? Actually, I've got the PDF right here, so I can just open it here. Alright, and then Kickstream on the side there. Okay. Perfect. I'll be able to watch the chat. And then we're good. Alright, perfect. Let me go ahead and transition here and start the study session. Alright, so we've got the periodic chart. Okay. Contains a lot of information, organized in such a way that enables chemists to note trends and patterns rather than memorize many facts. A periodic chart will be provided for reference during the test. Awesome. Oh, I was worried about that. All right. It used to be you had to memorize everything. Okay, information in the squares of the periodic chart. Okay, so example 1. Atomic number and atomic weight. So we've got lithium, sulfur, and krypton. Flow is part of the key to your periodic chart. Round atomic weights to 2 decimal places. I have a periodic chart that they gave us. So let me head over there and grab it. There's the periodic table. Okay. Lithium is Li. Atomic number is 3. What did I have to turn? Hold on. Round to 2 decimal places. Okay. So, open up that periodic. 6.94. Zoom in. Yep, 9.4. And then sulfur. Where is sulfur? Okay. sulfur is just S. Atomic number is 16. And the weight is 32.06. And then krypton is Kr. Atomic number 36. And weight is 83.80 rounded. Okay. Let's see, is that correct? Yeah. Oh, it said 32.07 for sulfur. I mean, the teacher said you don't have to be super exact with the atomic weights because the weight refers to different isotope. Not isotope. Is it? No. Different protons, neutrons, all that stuff. Excuse me. Taking a drink. Okay. Example 2. Groups, periods, and energy levels of the elements. Periods, that's what I forgot it was. Okay, so the groups, if you count over the top of the periodic chart, ignoring the transition metals, you get 1, 2, 3, 4, 5, 6, 7, 8 groups or columns, and each one responds to the number of electrons on the valence shelf. I think that's how you pronounce it. They're usually marked with a Roman numeral followed by a letter. Okay. Some periodic charts interchange the letters following the Roman numeral, but it is only the number that matters. Okay. Sorry, this is bugging me a little bit. I wanted to unlock some more of the spirit desk here. So it wants me to do some cooking in the pot and listen to the bubbles during lunch. Okay. Can we exit? Thank you. We're gonna go to the kitchen. We're gonna be simmering. Right? Yep. And it's gonna be lunchtime, so afternoon. And we're gonna listen to the tasty bubbling. So turn it down a little bit. There we go. Alright, let's get that back going. Going back again. Blech. The little Among Us is doing some cooking in the back there. There, let me hide the to-do list here. Don't need that up there right now. Alright. So, identify the group number. Oh, I need to do example 2. There we go. Identify the group number, period, and energy level of the following elements. Okay. Lithium. Sulfur. So doing the same ones as the last one. And krypton. Okay. So group number of lithium. Let me bring up that other periodic chart. Group number of lithium is 1. The period is 2. I should say I. And the energy level. Oh, I forgot what the energy level was. basically it has 2. It's gonna lose 2. So hold on. It has 3 electrons. Alright. 2 which are on... hold on. It's got 2 valence shelves, so it's 3 electrons. So it's going to lose 1 electron on the last valence shelf, which gives it a positive 2. Okay, so positive 2. Charge. Or energy level. The teacher was calling it charge, so I'm going to call it charge. Sorry. Alright. I don't know why, but taking a drink just makes everything go weird. Alright, sulfur. 2. Let's see. Sulfur is going to be hold on. I don't want to be signed into that anymore. Thank you. Okay, let's see. We're going 1, 2, 3, 4, 5, 6. So it's going to be the 6th one, or VI. And which period? It is in the 3rd period. And what's the charge? I do have some notes on this, but the charge on this one, let's see, it's got 16, it has 3 shelves, and it's going to have 6 on the last shelf, so it's going to take 2 from someone. So it's going to be a minus 2 charge. Because that's more, the electrons are negatives and the protons are positives, so if we get more electrons, there's more of a negative charge, so yeah, okay. Alright, and then the krypton, a little further down, that's going to be on 8. I think that's the Roman... Yeah, it's the Roman numeral for 8. Or no, is it V-I... I need to study back up on my Roman numerals. But I don't... I'll just write 8 on there instead. So... Oh, that is not the... Where did it go? Okay, so then it's got... What group? What group we're going? Or what period? 1, 2, 3, 4. Period 4. Alright, and then it's got 4 electrons on... or 8 electrons on the 4th shelf. So it's not gonna grab or take any from each other. I don't think we went over that one in class, or that row, when it comes to electrons and stuff. Okay. Let's see what it says the answer is. 4. Okay. Positive or negative? Hold on. It said B was a... Okay, it doesn't tell me whether it's positive... Oh, I guess technically, because it's just saying energy level. Across rows, periods are the rows of the periodic chart. Across the rows, 1 electron is added for each element. Each new row adds another energy level or new electron orbit. Huh. quite understand, but it's telling me that's the correct answer. Okay. I don't get it. Alright, that's fine, moving on. Don't have time to look at it. How many valence electrons? Okay, so A, we've got Na. B, we've got S, that's the sulfur, I remember that. Ca is C, and then D is just N. Okay, let's look at the table again. We're going to look at Na first. Where is Na? Oh, sodium is Na. And it is on the first, it's in the first group, so therefore it's going to have one valence electron. And it's on the third period, so it's going to be on the third row, but that's not what they're asking. B is going to be sulfur. So that one's going to have 2, 3, 6 valence electrons. C is calcium. Ca is calcium. And that's going to be in the second group, so that's going to have 2 electrons. And then D is N, which is nitrogen. And that's going to be in the fifth group, so it's going to have 5 valence electrons. Let's double check. 1, 6, 2, 5. Yes. Perfect. I got it right. Alright. Drink of water. I should update the title, because those things are for Twitch, which is not working for me right now because of my computer. I'm gonna get rid of those. Wait, no, that works with Stream Elements, which I have hooked up to everything, so cancel that. Let's not do that. Alright. I'm just so out of it sometimes. Alright, example 4. Shade the following areas of the periodic chart, each with a different shade. The representative elements and the transition elements. Okay, so I know the representative ones are the 2 blocks at the end, and the transition ones are that short block of rows in the middle. It's like the shortest block, so they're the metals in the middle of the chart. Many of these elements react in a way that can be predicted by the number of valence electrons they possess. Okay. Oh, stretch my neck. Sorry. Okay. Example 5. Specific regions of the periodic chart. Okay. Alright, let's see. A is He. B is V. C is Ca, which calcium. Ooh. My computer is struggling right now. That's not good. This is why Twitch doesn't work. Yeah. Okay, let's see. And D is number is N on the chart. Okay, He is a noble gas because He is helium. They've also got a chart in the book here that's got everything shaded in with the key as well. So let's see, that's why did I write helium? No. It's a noble gas. Noble gas. And B is V. Not sure what V is. What is V? Vanadium. However you pronounce that. That is a transition metal. Because it's in the middle. Metal. C is calcium. That one's an alkaline earth metal. Okay. Alkaline earth metal. Oh. Yeah, it's a metal. Yeah, it's a metal. Am I right in which one it is? Yeah, calcium is a metal. Huh. To be honest, I did not know that. Good to know. I always knew it was a supplement, and I mean, you do need iron as well, which is definitely a metal. D is N. Says one of the non-metals. What was N again? Nitrogen. Yeah. It's a gas, but it's not a noble gas. I think noble gas means it can't be mixed with anything else. Right? Or not mixed, but it can't combine with anything else. Yes. Can't combine with anything else to make a new compound or anything like that. Alright. Moving on. Did I get it right? Got it right. Sampled 6 metals and non-metals. Metals and non-metals. Okay, here's some stuff I need to make some notes on. Let's see. Properties of metal. It's got a luster or shiny. Shiny, shiny. Malleable. May be... Oh, I'm not writing that. Just says maybe beaten into a sheet, maybe with a mallet. Ductile, meaning it could maybe drawn into a wire like a duct. Also bends without fracturing. Alright, that part without... Oh. I'm just doing W-O. Fracturing. Okay. Conduct electricity. And heat. Alright, and then properties of non-metals. Okay, so no luster or dull. Dull. Give me a sec. Okay. Not malleable. Brittle. Not ductile. Also brittle. Does not conduct electricity. Hold on, I'll start the break in just a minute. Electricity. An insulator. Alright, and then identify which of the following traits or characteristics are metal or non-metal. Let's see. Has no luster. It's obviously non-metal. Conducts electricity, metal. It's metal. C is ductile, which is metal. D, not malleable, means non-metal. Alright, perfect. Alright, let's do our 5-minute break. Get up and stretch. Okay. Get some water. Walking in place. Just to keep things going. just too stiff. Too stiff. So I gotta move. Gotta move, gotta move, gotta move right now. Gotta groove, gotta groove, gotta groove right now. It's fine. It's a rainy day today. I don't know if it's a rainy day where you guys are, but it's a rainy day for me today. So yeah. It's not bad. I like rainy days. Although sometimes I do like sunny days. Rainy days are pretty nice too. Pick up my feet here, move a little bit quicker. Sorry, my knees bothering me, but not much I can do about it except stretch it out. Never really figured out how to stretch out that outside knee muscle. It's really weird. I've got one of those things that you use to like break down stuff, like the knots in your muscles, and I kind of use that for, it's like a massage stick or something, and I use that for the side of my legs, for that area there. But yeah, I don't know how to stretch that spot really. Except maybe crossing my legs. No, doesn't stretch that spot specifically, unfortunately. It really only bothers me after the chiropractor. So that's because they fix everything, and then my body's like, but you were never fixed to begin with. You were always lopsided, and now you're straight, and now we don't know what to do. It's like, okay. Stretch the muscles and work the muscles and hopefully build the muscles if it's not too late. I don't know if it's too late or not. So we'll see. As long as I keep at it, I'll at least keep the muscles I do have. Alright, got 10 seconds left till we are back from the break. Back to studying. There we go. Alright. Another sip of water. Alright. There we go. Whew. Continue. Alright, example 7. Heat transfer and temperature. So the heat capacity of water is 4.18 J/G/degrees Celsius, and aluminum's heat capacity is 0.902 J/G degrees Celsius. It takes less energy to raise the temperature of 1 gram of aluminum by 1 degree Celsius than it takes to raise the temperature of 1 gram of water by 1 degree Celsius. Why? Oh dear, okay. This question is actually based on something you already know from personal experience. An aluminum spoon placed on a hot stove gets hot very quickly. Water takes a relatively long time to reach the same temperature. The stove is the heat source and is providing energy measured in joules. Okay, that's right. I should know this from my intro to electronics. Or calories to the spoon and the water. The applied heat energy causes the temperature, measured in degrees Celsius, of the objects to rise. As you know from personal experience, when the same amount of heat is applied to different objects, the temperature increase may be quite different. To put it another way, some objects require less heat to be applied to increase 1 degree Celsius in their temperature. This observation depends upon the heat capacity of the objects. The heat capacity for water is relatively high compared to other materials, 4.18 joules per gram per degree Celsius. By comparison, aluminum has a lower heat capacity, 0.902 joules per gram per degree Celsius. Note how it takes less energy to change the temperature of aluminum than it does to change the temperature of the water. Okay, so basically it takes sorry. Sorry, my brain just shut down. 0.902 joules of energy to increase the temp of 1 gram of aluminum by 1 degree Celsius, which is less than the 4.18 joules of energy per gram of water. Okay, how much heat would be needed to raise the temperature of 100 grams of water from room temperature 22.000 degrees Celsius to boiling 100.000 degrees Celsius, given the specific heat of water is 4.18 joules per gram per degree Celsius. Keep in mind that temperature is not the same as heat. Heat is a form of energy. Temperature can be used as an indicator of how much heat energy an object has. We can solve this problem using the formula heat Q, it's not a Q, Excuse me. Hold on one moment. Had to cough there. Alright, heat Q is equal to mass times specific heat times change in temp. So this is going to be heat Q is going to equal 100.00 grams times 4.18 joules per gram per degree Celsius times 100.000 minus 22.000 degrees Celsius. Going to equal 32604 joules or 32.604 kilojoules. Excuse me. Doing a lot of talking today. Might have to have some lemon tea with honey after this. The concept of specific heat can be related to the early discussion of metals and non-metals. It was stated earlier that metals are good conductors of heat, while non-metals are poor conductors of heat. This observation can be exemplified by comparing their heat capacity or specific heat values. For example, gold, a metal, has a heat capacity of 0.128 joules per gram per degree Celsius, while sulfur, a non-metal, has a heat capacity of 0.720 joules per grams per degree Celsius. It is a general observation that it takes more heat to raise the temperature of a non-metal than a metal. There are many exceptions, though. Hold on a second again. Okay. I'd have to stop talking for a minute or two. I'm not used to talking so much. Gotta get back into it. Or just, talk a little quieter, maybe? I don't know. We'll try that. How's that sound? Trends in the periodic chart. Okay, I see now. In the following list of elements, identify the least electronegative, the one with the highest ionization energy, and the one with the smallest atoms, P, Zn, and Y. Where's Ze? Or Zn, not Ze. Oh, okay, it's one of the transition metals. And Y is one of the transition metals is no? Yes. Yes, one of the trans. Okay. Electronegativity is a relative measure of the strength with which an atom pulls electrons towards its nucleus. An element with a high electronegativity pulls very strongly on electrons. Okay. The least electronegative is Fr, which is francium. Highest ignition energy. We're looking for the highest, which is He, or helium. And then the one with the smallest atoms. The distance from the nucleus to the outermost electron. Helium is the smallest atom, and francium is the largest. But it said just tell it which one out of P, Z, N, and Y. It would be P, which is phosphorus. That's the smallest out of the three. Right? Least... Oh, okay. I had to do it out of the three, so... The least electronegative is Y. Highest ionization energy is P. And P is the smallest atoms. Okay. 0.3 to 1.9. So Mg is polar covalent, and then the other two are ionic. Non-polar covalent 0 to 0.2. So this would be ionic. No, hold on. Ionic. Oh, sorry about that. So this would be covalent, and then this one would be non-valent. Okay. Okay, I got it right. Perfect. That's awesome. That one clicked. I like it when stuff clicks. It's helpful. This one has one atom of oxygen. This one has 2 atoms. This one has 3. This one has 6. Wait. This would be 9 because we're multiplying these two. Okay, so yeah, 9. Multiplying those two. The other ones I got right, though. Yay! computer. Yay, got him right. Alright, how many more of these do I have? Okay, I've got one more example and then some practice questions, and I'm done with this module. I just remembered I need to start reading through Module 3. Great. Love it. Love it, love it, love it. Level 12. Oh, my new eyeglasses already. Dang it, I can't pick those up today. Unless I end the stream now, but I've still got more studying to do. Can't leave this till tomorrow. And I need to go to the bathroom after I finish writing this question. Alright. Excuse me. I will be back. Might be longer than 5 minutes if my parents need anything, so I'll be back. Oh, I'm not on mute. So you don't have to hear that. Okay, here I am. I'm back. Sorry. A little bit longer than 5 minutes. Okay. Questions. Okay. Sorry, I'm quiet. Like I said, my throat's been bothering me now, so gotta save the voice. Like I said, though, I'm gonna be drinking some tea with lemon and honey after this, so. Alright, so, practice assignment for Module 2, periodic chart. Ooh. And my foot started hurting for some weird reason. Alright, number 1, state the symbol, atomic number, and atomic weight for each of the following elements. A is bromine. B is bismuth. C manganese. D arsenic. E xenon. Okay, let's look at the periodic table. Bromine. I know it's very heavy. Oh, here's bismuth. We're gonna do Bi. Atomic number 83. Let's zoom a little bit again. What is that? 208.98. There we go. Alright, and there's bromine. 35. Oh, hold on. It's BR. 35 is the atomic number 79.904. Right? Yeah. Is the atomic weight. Okay, manganese. Well, I see xenon right off the bat, so I'm just gonna do that one real quick. Atomic number 54. Weight 19. No, is that 13? Oh, gosh. I hate I have to zoom in so much. One 131.29. Okay. Now we're looking for arsenic and manganese. I see arsenic. It is AS, atomic weight of, or not, atomic number 33, atomic weight 74.922. Manganese. Is it magnesium that they're trying to... Because I see magnesium. No, here, one of the transition metals. I can't pronounce it. Atomic number 25, weight 54.938. Cool. Alright, number 2. State the group number that includes each of the following elements. Phosphorus and bismuth. Barium and I know this one's number 8 right off the bat. Okay, let's see. For phosphorus and bismuth, I saw bismuth not long ago. There it is. Group number 5. Barium and magnesium is group number 2. Boron and aluminum is group number 3. I should be checking these at the answer key. That's correct. That's correct. That's correct. That's correct. That's correct. 5, 2, 8, 3. Okay, perfect. State the period number that includes each of the following elements. Calcium and zinc. Hydrogen and helium. Strontium calcium and zinc. It's going to be 1, 2. It's going to be number 4. The fourth period. Hydrogen and helium is in the first. Number 1. Strontium and tin. Fifth one. And chlorine and argon in the third. Alright, let's check. A is 4, B is 1, C is 5, D is 3. Perfect. Number 4. Indicate the number of energy levels that an atom of each of the following element has. A. Strontium. B. Lithium. C. Mercury. And D. Helium. Pretty sure helium has 4. No, wait. Where's helium? Helium's all the way over there. Energy level regarding valence? Or the number of valence electrons? I think it's the number of valence, so helium would be 1 in that case. Strontium would be 1, 2, 5. Lithium. Where's lithium? Would be 2. And mercury. Where is mercury? That one would be 6. Let's check and see how wrong I am. Oh, where's number 4? It's 5, 2, 6, 1. Oh, okay, so that is correct. Number of valence shelves. Number 5. Indicate the number of valence electrons that an atom of each of the following element has. Oh, okay, this one's an easy one. Okay. So, potassium has 1 valence electron. Aluminum has 3. Argon has 8. And silicone has 4. Let's see how right we are. 1, 3, 8, 4. Yay! I got it right! Woo! This helps a little bit. Not much, but a little bit. Alright, number 6. I identify each of the following as an alkali metal, alkaline earth metal, non-metal, or noble gas. So we've got cesium, sulfur, calcium, neon. Pretty sure neon's a noble gas. Calcium is an alkali earth metal, I think. Sulfur, I'm pretty sure is a non-metal. Cesium, where is cesium? I want to say that's an alkali metal. I'm not sure. I have a feeling I got these wrong. Actually, oh, I did get A right. Okay, B is right, C is right, and D is right. Yay! I was actually surprised. I'm pretty sure I got B, C, and D right. But A, I thought I was definitely wrong on. Number 7. Identify each of the following properties as characteristic of metals or of non-metals. This one's gonna be easy. Conducts electricity. That's a metal. Ductile. C. Not malleable. Non-metal. Let's double check. Number 6. No, number 7. Metal. Yes. Metal, yes. And non-metal. Huzzah! Oh, it's going to be a tough one. For each of the following groups of elements, list them in order of least electronegative to most electronegative. It's K, C, U, E, R. N, A, S, B, I. Actually, now that I think about it, it's actually not that difficult. It's I, E, F, R. I know this one, F, R is least. And D, F, C, S, N. Okay. Let's go back to the periodic table. Spelling. Okay, where is K? Where is CU? that one didn't need to change. Nitrogen, arsenic, bismuth. Bismuth, arsenic, nitrogen, I think. Alright, FR was definitely RB and LI. This one F is towards the end. C is SN. Do SN, C, F. Okay, let's see how I did with number 8. KCUBR, correct. B, BI, ASN, cool. This one, FR, RB, LI, and DSN, CF. Yes. Huzzah! I did it. Number 9. For each of the following groups of elements, list them in order of lowest ionization energy to highest ionization energy. KCBR. Same ones, actually. Oh, this is supposed to be B. Oh, they're going to be using the same ones for number 10, too. Okay, so I think lowest ionization starts from there, and then the highest is here. Okay, so was it lowest to highest or highest to lowest? Lowest to highest, okay. Lowest ionization. BR. And potassium. No, it'll be the other way around, right? S, I. Lowest ionization to the highest. There's RB there. Okay, so LI, RB, FR. FC, BSM, SM, C, lowest to highest, C, and then minus F, right? No, SN, VF, SM, C. Okay, let me check. I have a feeling this is all wrong. That is wrong. It should be K, C, U, B, R. Okay. Also wrong. Should be B, I, A, S, N. What? This is wrong. What did I do wrong? F, R, R, B, L, I. And this is wrong. That should be S, N, C, and F. I don't know what I did wrong there. Alright, well anyway, I get a 5-minute break. Get up a little bit. Got you for life. Hello. Hello, W. Dill. What is up? I'm just on my 5-minute break. Let's see what I got here. I got the little capybara thing. Capybone. Alright. Turn off the bubbling sounds. What's the next one? Chop veggies. What sounds the kitchen motivate you? Early morning. Veggies, early morning. Chopping. Sounds of kitchen. Early morning. Kitchen ambience. There we go. Okay, cool. Alright, just gonna stretch a little bit. About 3 minutes till I'm back to it. And then this next section, after the next section of studying, it will be time for the 30-minute break. Oh, who did I knock over? Oh, okay. But yeah. It'll be a 30-minute break. I think, let's see. I'm wondering if I should end stream then. But there's still more studying I need to do. Like I said, I still gotta do Module 3. Module 3! Module 3 studying I gotta do, and I wanted to do more of 11.3. So you know what? I think I'll just do the BRB screen when I get to the 30-minute break. And then I'll just take my 30-minute break. Maybe get a snack or some, because I had a late dinner. Because I can't go without food technically, but it's too, like I said, I had a late lunch, so there's that. Yeah, I'll just get a snack. Maybe throw up some music. I'll put some chill music on during the 30-minute break. whatever the music is that they have in the game. I hope it's safe for YouTube, because otherwise I'm SOL. I have to go back and edit stuff later. Okay, so what did I do wrong though? On that number 9. Lowest ionization energy to highest ionization energy. Where did I go wrong with the ionization? That's electronegativity. Yeah, I hear ya. That's ionic atomic radius. Largest, smallest. Ionization. Oh, okay. That's what it was. I feel stupid now, but it's okay. Alright, continuing next section. Let's go. Okay, number 10. For each of the following groups of elements, list them in order of smallest atomic radius to largest atomic radius. And it's the same ones as the last two. This one I'll look up. Alright. Let's go look at the radius, atomic radius. So, for largest to smallest, or smallest to largest? Smallest to largest, okay. So, smallest is in the top, so then K is going to be the largest. So B, R, C, U, K. NASBI. So BI is going to be BI is going to be the largest, AS smallest, and N is smallest, huh? Okay. Once again, what am I doing? Definitely need that break. Smallest, so this is largest. This is going to be N, A, S, B, I. Smallest. FR is largest. It's going to be LI, RB, FI. And this one, F is going to be smallest. then C, then SN. Okay. Let us check. It's number 10. BRCUK, yes. NASBI. CLIRBFR, yep. FCSN. Perfect. Alright, now number 11. For each of the following atoms and their ions, circle the one out of the pair which is larger. A, K, and K plus, B, F, and F minus, C, SC, and SC3 plus. K plus means it lost an ion, so this one is going to be the largest. This one's going to be the largest, and this one's going to be the largest. Actually, no. That one's going to be the largest. Let's see if I did that right. I should have... Okay, so that one's right, that one's right, that one's wrong. I should not have second guessed myself there, because I got it right the first time. Alright, moving on to number 12. Number 12, people, number 12. For each of the following chemical formulas, state the type and number of each atom in the formula. Oh boy. Number A, we've got KOH. B, we have Ca and Cl2. C, we have AlOH3. D, we have NH4, 2, and SO4. And E, we have Fe2 and SO4, 3. So this one I know we have, okay, we have one of, O we have one of, and H we have one of. What's the type though? What does it mean by type? Oh, it just means, okay. Just means I go like this, K1, O1, H1. This one's going to be Ca1. This one's going to be Cl, 2 of them. We've got Al, we've got one of those. Colon. And then OH. Actually, we have 3 O's and 3 H's. This one, we have we have 2 N's. And 8 H's. We have 1 S. And 4 O's. And then this one we have 2 Fe's, or irons. We have 3 S's and 12 O's. Alright, let's double check. Number 1 is right. Number 2 is right. Or B is right. C is also correct. D, 2 N's, 8 H's, 1 S, 4 O's. Yep, D is right. E, 2 FE's, 3 S's, 12 O's. Those are correct. Perfect. Number 13. Given the following electronegatives, what type of bonding would be expected between pairs of atoms indicated? Okay, so H is 2.1, C is 2.55, Cl is 3, oh, let's write down Cl. Cl is 3.16, A, H, and H, B, Cl, and Cl. This is nonpolar. Whatever it is, this is nonpolar as well. C is going to be C and Cl. D, C, and H. So 3.16 minus 2.55. 0.61, that's going to be it's going to be polar. And then C, 2.55 minus 2.1, 0.41. I think that's going to be nonpolar, right? Alright, let's check that. Covalent, that is what? But, that is right, nonpolar covalent. That was right. Nonpolar covalent. Also right. This one was a polar covalent. So that was right. This last one, I got wrong. This was a polar covalent. Alright, number 14. Energy in the amount of 0.385 joules supplied each to a 1 gram copper rod and to a 1 gram of silica, which will show the greater increase in temperature and why? Copper rod, because the heat capacity of the copper is lower than the silica. Let's see if that's right. Therefore, the heat of sand will only increase by a fraction of a degree, unless in this case, a copper rod experiences a greater increase in temperature. Yes, they did it with more words, but I was right. State the 3 laws associated with mass and energy. last one, I'm not so sure. Matter is neither created nor destroyed. I got it right the first time, so. But yeah, energy is neither created nor destroyed. Yep. The total amount of mats. That one was wrong. Alright. Total. Gotta memorize these. Of mass and energy in the universe is constant. Alright, let's go to number 16. Identify each of the following elements as an alkaline metal, an alkaline earth metal, a transition metal, a non-metal, or a noble gas. Alright, Ne, Ag, Cs, oh, no, not Sc. Completely different. Grab a drink. I still got 8 minutes on this section. Okay, anyway, let's bring up the periodic table. Ne is neon. It is a noble gas. Ag is silver. That is a transition metal, right? Yeah. Alright, CS, what are you? Cesium. That is going to be an alkali metal. Magnesium is an alkaline earth metal. And I don't know what P is. Let's double check which one that is. Phosphorus. That's a non-metal, right? Alright, let's check it. A, noble gas. B, transmission metal. C, alkaline metal. And E, non-metal. Perfect! Alright, 17. Distinguish between the locations of representative elements and transition elements on the periodic chart. I have to draw it. Yeah, I'm gonna skip that one. So I can see it in my head, but I just don't want to draw it. Alright, we'll go to number 18. Given the following electronegatives, what type of bonding would be expected between pairs of atoms indicated? Na is 0.9, S is 2.6, O is 3.4. So A, Na and O, B, S and O, D, C, no, I skipped C, N, A and S, and then D, O and O. So N, A and O, so that would be 3.4, 0.9, 2.5, that's going to be ionic. Let's see, that is 3.4 minus 2.6. That is going to equal 0.8, so that's going to be polar covalent Na and S, so 2.6 minus 0.9. 1.7. I think that's ionic. This is going to be non-polar covalent because it's 0. Let's double check here. Number 18, ionic. That is correct. Polar covalent, correct. This one is not ionic. It is a polar covalent. And then the last one, non-polar covalent, correct. Alright, 19. Indicate the number of valence electrons possessed by an atom of each of the following elements. A is barium. B is helium. Move this up. C is hydrogen. D is sulfur. What I did there. Alright. Barium. Where's barium? There's beryllium. Barium. Here we go. You have 2 valence electrons. Helium has 8. Hydrogen has 1. Sulfur. Where'd sulfur go? Oh, there it is. It has 6. Let's double check ourselves. Sorry, it keeps cutting in and out with the sound. I totally got that wrong. I got helium wrong. What did I... Helium, where's... Helium's all the way at the end. It's got 1 valence shelf. And it's got 8... It's got 8 electrons on that 1 valence shelf. It's like the other ones were right. So why was that wrong? Did they just do it wrong in there? They must have put it in wrong. I'm just gonna move on. Number 20. In the following list of elements, identify the most electronegative, the one with the highest ionization energy, and the one with the largest atoms. O, S, A, L, N, A. So, the most electronegative. I believe that would be oxygen. Highest ionization energy. most electronegative. Okay, I'm confused. Also has the most ionization. Alright. And then which one has the largest atoms? That's probably... Where is it? An A? That wouldn't be an A, right? No, it is. Okay, yeah, because... Largest atoms. Okay. Okay, thank you. Alright, let's double check this. Sorry about the spam in chat for you Kick viewers. Let's see, so O is the most electronegative, O has the highest ISA, and A has the largest atom. Okay. So we're good. And then number 21. How many atoms of hydrogen are in each of the following chemical formulas? So, A, we've got FeOH3. B, we have NH4OH. C, we have HCl. And D, we have C6H12O6. So we've got 3 hydrogen here, 5 hydrogen here, 1 hydrogen here, 12 hydrogen. Let's double check. A is 3, B is 5, C is 1, D is 12. Okay. Great. So we're done with this now. We're done with module 2. Yay. Oh, I'm happy. Okay. So I'm going to do the 30-minute break. Get a snack. And like chill for a bit. And then when we get back, we'll be working on module 3. And then if I have some time, I'll be working a little bit more on 11.3, what you call it? 11.3 homework. That's it. Alright, let me go ahead and transition to the BRB screen, and I will BRB. Okay, I am back. Give me one moment. I gotta reset some things. Get some new notes put together for module 3. Okay. Hello, hello, hello. I am back. Welcome, welcome, welcome. Let's see. I do need to download the next module, unfortunately. Let me get this started sharing as well. Excuse me. Oh, connect tab. I need to do that first. There we go. Excuse me. Oh my goodness. Come on now. There we go. Over a little bit. Okay. Whew. I've been streaming, or the streams have been running for 2 hours and 40 minutes. Oh boy. That's a long time. That's a long time. Let me get... Oh, look, it's a little carrot knight. That's cute. I gotta figure out how to unlock the train one. I like that one. Alright. Yep, we got it. Squire Sprout. So let's do a mushroom one. Scrub and rinse your plates thoroughly. Make sure to clean up after dinner. Turn on a vinyl to help get into the flow. Okay, so we're gonna do soft vinyl noises. And lighting is gonna be evening, I believe. And we're gonna be doing dishwashing. There we go. Perfect. Thumbs up. Now, give me a moment. That is my files. No, I need to go to modules. Did module 1. Oh, there's some videos I should be watching. Module 3 also has videos I should be watching, but I just can't. Nope. Just can't. Not today. Alright. Module number 3. Gonna download it. Go to the downloads folder. And we're just going to drag this over to here. Upload complete, and just gonna open it. Perfect. Alright. Module 3. Let me take off the notes. Oh, let me switch so you guys can see a little bit better. There we go. Much better. Alright, so module 3, we've got measurement. I hate measurements. Alright, you know what? I'm just gonna do one block of this. And then, you know what? think I might call it a night after that. Because I did have a snack, but I need to have dinner too. So I might call it a night after this. But I will definitely be trying to stream tomorrow. Be doing more 11 point... Well, I'll probably finish up the 11.3 homework on my own before streaming. But I'll definitely finish up Module 3 notes and start reading through 11.4. 11.4 for the calculus. So, yeah. It'll be a late... I think I'll try and start 11.4 as well in between classes. So we'll see. I definitely need to do a lot, as evidenced by today. I got to do a lot every day, every day, every day. Ugh. So tired. Okay, so they're just basically like, oh, you gotta include the units. Let me just go ahead and start the session. But yeah, they're like, oh, you gotta make sure you include the units and all of that stuff. Make sure to always write down the units to very useful relationship to remember. You know what, let me go ahead and write down the study tips. Study tips. Number 1. Always write down the units along with the measured values or conversion factors. Number 2, a very useful relationship to remember is that 1 centimeter cubed is equal to 1 ml. And number 3, pay particular... It's not really reading my lips very well, is it? It's because I moved so much since when I first calibrated. Pay particular attention to conversion factors in problems involving cubic units. It is easy to make mistakes with these problems. Okay. might need to just print out the useful conversion factors sheet here. Some of this I recognize from Intro to Electronics, so that's not too bad. Which is good. How to use dimensional analysis to set up and solve problems. All measurements made in chemistry have units, such as grams, liters, meters, which must be written along with the number. Units may be added, subtracted, multiplied, and divided as if they were numbers. Units may be extremely helpful to ensure that calculation is properly set up. Conversion factor is a relationship between two different units written as a ratio. Okay. Whew. Okay. One. Okay, let's see, for example, how many quarts are in 2.00 liters of soda? Blank quart equals 2.00 liters times 1.056682 quart divided by 1 liter. Find equal given times conversion factor with proper significant figures that equals 2.12 quarts. Okay. Significant figures. Oh, why did it do that? Is it because because I'm leaning. It's probably because I'm leaning. Blah. Excuse me. Is it weird if I find that the math, like the Calc 3, is more organized and understandable than the chemistry stuff? Oh. Oh, it sucks. Okay. It's fine. I'm gonna get through it. I'm gonna get through it. I'm gonna get through the class with at least a B. But I'm gonna shoot for an A. So yeah. An A or a high B. That's what I'm going for. Oh, but I suck. Okay, it's fine. Almost every number used in science has a measurement. Measured value should indicate the accuracy of the measuring instrument used. Correct number of significant figures includes all accurate numbers plus one approximation. Case A, we have 100 mLs and 200 mLs and a measurement of 150 mLs. Sure of first digit, second digit is an approximation. No confidence in third digit, so it is assigned a value of 0 and is included as a placeholder. First two digits are significant, one sure plus one approximate. Case B, we have a 200 ml and a 201 ml, and the measurement is 200.0 ml. Sure of first three digits, fourth digit is approximate. 4S dot F, 4 significant figures. 3 sure plus 1 approximation. This measurement is more accurate than case A, 4 significant figures versus 2 significant figures. Okay. So we've got rules. Lovely rules. Rules. Don't like rules, but we gots to have them. Gots to have them to function. Alright. Because if there were no rules in my life, I would spend all day in bed. Just sleeping or watching YouTube. Maybe getting up every once in a while to play Final Fantasy. But that's it. That's all I'd be doing. Heck, I'd probably try and figure out a way to play Final Fantasy from my bed. Okay. I don't want to try and do that until I actually cannot move out of my bed anymore, which hopefully won't be till I am 80 years old. Heck, hope I'm like my grandpa, who was still getting around at 90. He lived till he was 99. Pretty awesome. I can't focus. Oh, this is not good. Still got like 12 or 13 minutes on the timer, but okay, I can do this. I'm gonna get through it. Let's just write down the rules and then continue. Pretty significant figures. Man, this is a lot for this number 3. So is number 4. Ugh, whatever. Maybe I'll be done with the timer by the time I finish copying these rules. How's that everyone doing? Don't do that. Significant. These are often called placeholders because they give indication of numbers, size, because they are not significant does not mean they are not there. They just a no part in the numbers number. If there is no decimal point, trailing zeros are not significant. Okay, I'm not gonna copy the rest. Alright, let's see. Oh, no, I didn't want bold just yet, because we've got a 0.000, and then a 9320. 4 significant figures. And the other one, 3, 4, 5, 0, 0. 3 significant figures. It is preferable to express this with scientific notation to remove all doubt. Okay. I see. So basically, such as 3.45 times 10 to the 4th, 3 significant figures, got 3.450 times 10 to the 4th, 4 significant figures. Or 3.4500 times 10 to the 4th, which is 5 significant figures. Alright, now rounding. If the digit is to be dropped, the digit after the last significant figure is less than 5, the last significant figure does not change. Round each number to 3 significant figures. Okay. The digit to be dropped is 5 or greater. Okay, that's just kind of standard. The last significant figure increases by 1. Yeah, that just kind of is how it is in math. Addition, calculations involving significant figures, addition and subtraction, round the answer to the least number of decimal places, yes. Multiplication and division, round the answer to the least number of significant figures. Answer contains least number of significant figures. Answer can be no more accurate than least accurate number. Okay. Powers and roots, same rules as multiplication and division. Okay. So basically just least number of significant figures. Okay, and then it's got a worksheet and the answers, and then examples of measurement problems, temperature conversions, and then a practice assessment on measurement again, and a supplementary measurement worksheet. Okay, so You know what? I think that's a good stopping point. Since it's already giving me a practice worksheet. And I really don't need to read through the whole thing tonight. And we've got 5 seconds anyway. Yay! I am so tired and done with studying. Oh man. I gotta do another Pretty Derby stream at some point. I've been playing a bit off stream, so I've been having a little bit of fun with it. But yeah, I'll have to do that. Alright, let's turn this off. I'm gonna switch over to my VTuber model only. And may as well just make that big. Alright, so thanks for stopping by, if you've stopped by. I will see you guys tomorrow for a shorter stream. Hopefully a longer one on Wednesday. Like I said, I gotta stop at the seamstress, and hopefully I don't have anything else due. I don't think I do. So yeah, there's that. Wednesday will be a little longer. Thursday, once again, a short stream. Friday, short stream. Saturday will be depending on if I'm working or not. As of now, I am not working this Saturday, so that could change in the next few days, all depending on what happens. But if I'm not working, I will be streaming, and that will be a longer stream. That one I might try to do, I might try to do studying and gameplay on Saturday. Because I gotta have a break some point, you know. Can't just study until I drop. Because that's not healthy either. But I do need to spend most of my time studying. So yeah, I'll try and do studying and then a gaming stream. Sunday will be my day of not streaming. I might do a little bit of studying on Sunday, but mostly just resting. And then another stream on Monday. Another long one like today. And hopefully I will get started earlier and be able to do a gaming stream afterwards. So yeah. Alright. I will see you guys next time. You have a good one. Bye!